In his seminal work titled The Origin of Species, English naturalist Charles Darwin expounded on the concept of natural selection, suggesting that only those organisms that are best adapted to the conditions of their life are most likely to survive. In its simplest form, the concept of evolution represents the view that the ordering principle of reality is the survival of the fittest.
In their bid to survive, animals use some special features bestowed upon them by nature to guard against enemies. The use of poisonous glands by snakes is also a part of this mechanism, but has earned the crawling organism notoriety and awe like no other animal. Snakes fascinate and snakes repel. Some pose a danger, while most others are harmless. Regardless of whether they are seen as slimy creatures or colorful curiosities, snakes play an important environmental role in our fragile ecosystem. People who frequent wilderness spots, as well as those who camp, hike, picnic, or live in snake-inhabited areas, are aware of the potential dangers posed by venomous snakes. A bite in which the snake may inject varying degrees of toxic venom could readily result in a medical emergency. In India, snake bite is a significant problem, with as many as 20,000 deaths a year, whereas many cases go unreported. There are 4 major poisonous snakes in India, namely cobra, Russell's viper, common krait, and saw-scaled viper.
Over the years, snakebite victims have been exposed to all kinds of slicing, freezing, and squeezing as stopgap measures before receiving medical care. Some of these approaches, like cutting into a bite and trying to suck out the venom, have largely fallen out of favor. In the rural areas of India, where snake bites are rampant, tens of hundreds of snakebite patients run the risk of dying in the absence of timely availability of medicine. Notably, antivenom is the only treatment for snakebite if there is significant systemic envenoming. In situations where the bite can prove lethal, antivenom is a way of rescuing the patient from the clutches of death.
Antitoxin and Sera Department of the Hafkin Biopharmaceutical Corporation Limited, based at Pimpri, Pune, has been manufacturing antivenom, also known as snake antivenin, since over 6 decades. The corporation has been named after the famous Dr. W.M. Hafkin, who is said to have single-handedly controlled the Black Death or the plague outbreak in 1896 by developing a vaccine against the dreaded disease. As a mark of respect to his pioneering work in setting up the Plague Research Laboratory at Mumbai, the laboratory was renamed as the Hafkin Institute in 1925.
The snake venom is a mixture of many toxic factors, and the composition of venom varies from snake to snake, and the effects on the body of the bitten person depends on which variety of the snake has bitten. The effect on the body can be categorized into 2 parts. The first is local effects and second is the generalized effect. The local effect can be seen as pain, swelling, necrosis or secondary bacterial infection, and the systemic involvement, it varies greatly from the venom from one snake to another. In the venom of Elapidae family, its principal action is on the nervous tissue of the person, and the second effect is on the cardiovascular system, whereas in the venom of Viperidae family, the predominant action is on the hemopoietic system, and it is manifested mainly by the hemorrhages, which occur mainly due to the damage to the blood vessels or due to interference in the blood coagulation mechanism.
The snake farm is maintained since 1995 by the Anti-Sera Department at the Hafkin Biopharmaceutical Corporation, Pimpri, where the venom of poisonous snakes is collected on a regular basis, which is used for hyperimmunization of equines at the farm. The horse farm located in the same premises houses about 500 horses and mules that are used in the production of anti-venom.
Of the anti-venoms currently being manufactured worldwide, about 97% comprise horse antibodies or their fragments. Equines, such as horses, mules and ponies, have been used for the production of hyperimmunoserum for over 100 years now. It is a warranted choice due to certain advantages, such as the ease of handling the animals, their tolerance to repeated high dosages of antigens, and their ability to yield high volumes of blood at periodic intervals.
The antisera are produced by hyperimmunizing the equines by injecting antigens at periodic intervals with gradually increasing dosages over a period of 6 to 8 months. Once the equines attain a certain level of potency against the antigen, their blood is collected once every month. Before collecting their blood, a complete physical checkup of animals is carried out, and only fit animals are taken up for blood collection. Prior to blood collection, insect repellent antiseptic spray is used to avoid infection from flies and insects and to avoid distraction to animals.
The maximum quantity of blood collection is restricted to 1.5% of animals' body weight per collection. During the collection process, blood is shaken continuously to ensure proper mixing of anticoagulant solution with the blood to avoid coagulation. The hypovolemic shock treatment kit containing all necessary medicines is kept close by to meet any kind of emergency situation. The blood is allowed to stand overnight between 2 degrees and 8 degrees centigrade for the red blood cells to settle down.
Next day, the plasma is separated from cells, and this plasma forms the basic raw material in the production of antivenom. As the red blood cells are not useful in production processes, they are resuspended in saline and returned to the animal next day. This process is called plasmapheresis. It helps the animal to maintain its hemoglobin and red blood cell count in the normal range and avoid anemia due to regular blood donation. Great caution is taken to ensure that the blood is returned to the correct animal from whom it has been obtained earlier. The separated plasma contains specific immunoglobulins or glycoproteins that are secreted by plasma cells and that function as antibodies in the immune response by binding with specific antigens. The separated plasma is further processed by enzyme digestion and chemical separation to obtain purified equine immunoglobulins.
The stages of processing blood for antivenin production include blood of hyperimmunized equine, blood cells returned to animal, plasma, ammonium sulfate precipitation and pepsin digestion, filtration, precipitate discarded, filtrate, ultrafiltration, serum containing purified immunoglobulins. The Institute is well equipped with most modern production and quality control equipments. The production facility conforms to World Health Organization Good Manufacturing Practices guidelines. The institute has its own strict in-house quality assurance norms to ensure best quality finished product. A modern lyophilization plant having computer-controlled lyophilizer, which can produce about 8,000 snake antivenin vials in one cycle, has been recently commissioned. Lyophilization or freeze-drying is a process wherein water is removed from a frozen liquid product by evaporation, and hence the product retains all its physiochemical characteristics. The advantage of freeze-drying is that it allows the product to be stored at ambient temperatures and do not need refrigerator for storage. As most of snakebite cases are in remote far-flung areas where there is no electricity, storage of life-saving medicine like snake antivenin can be a problem. To overcome this drawback, the product is lyophilized for ease in handling and storage.
After lyophilization, the serum is available in powder form for ease of storage. The finished product is then tested for potency and safety on mice and then sent for distribution after labeling and inspection. As the production of snake antivenin is done by using equines, a lot of veterinary care needs to be provided to ensure that the animals remain healthy. Their proper housing, cleanliness of stables, keeping the animals clean by daily grooming, providing regular hoof care, identification of sick animals, and proper treatment is a very important task. The equines are provided with nutritious food consisting of concentrate mixture, leucine grass, green maize, sprouted gram, hay, etc., so that animals do not lose body weight due to repeated blood donations.
All in all, this is a perfect example of symbiotic coexistence, a far cry from the prevalent apprehensions about the violation of animal rights for human comforts. Quite unruffled by all criticism and driven by its mission of service to mankind, Hufkin Biopharmaceutical Corporation Limited continues to ensure that snakebite victims get a new lease of life.